Okay, so welcome back. Today we're going to talk about a little bit more about trigonometry and something we call the unit circle, which is something very important to us in the world of trigonometry. And we'll look a little bit about what the unit circle actually is and what it means to us and its significance and why it is so important. So let's talk a little bit about the unit circle and how trig functions work. When we look at that, first off, the unit circle is called the unit circle because its radius is 1 unit, whatever that might be that we're dealing with in our units. It might be inches, it might be feet, it might be miles, it might be light years, who knows. But anytime we're dealing with a unit circle, our radius is 1 of whatever unit that is that we're dealing with. When we use the unit circle and we have an angle in standard position. We talked about that yesterday. We had a standard position where our initial side of the angle was on the x-axis and our terminal side rotated around to a certain point, and that defined the measure of our angle. So our unit circle, or our circle, is formed by the rotation of that terminal side, and wherever our terminal side is going to end up, it passes through a point on that unit circle. Now that point is very significant to us because we know the radius of the unit circle is 1. So because of that, we can use that point that the terminal side is passing through to identify all the trigonometric functions of the angle that is formed between the initial side and the terminal side of that angle. So I know that's a lot of new terminology at you, and I know we talked about initial and terminal sides yesterday, so it's still fairly new with you. So let's take a look at exactly what we're talking about here. Just continuing along, when our terminal side is passing through a coordinate x, y, any coordinate, because of the situation that we've created, and we're going to take a look at this in just a second, our coordinates x, y are going to help us define the sine value of that angle. First off, the y coordinate that is given by that coordinate xy will be our sine value for the angle. If the terminal side is passing through xy, the cosine is also going to be equal to the x coordinate. So why does this happen? Well, let's take a look. If we were to look at an actual, first off, let's look at these things we've talked about before. We call these the 30, 60, 90 triangle and the 45, 45, 90 triangle, which are named for the measures of the angles within those triangles. And if you'll remember, we said that the shortest side, which is across from the 30-degree angle, if that had a measure of x, whatever that measure is, if it's 5, if it's 8, if it's whatever that length is, we can find the longer leg by taking that length and multiplying it by the square root of 3. And that happens every time we have a 30, 60, 90 triangle. Well, if we take the shorter side again, that x value, and we want to find the hypotenuse, we just simply need to double that value, and that tells us whatever the hypotenuse is. Now, knowing this is very important for us. And going to the 45, 45, 90, well, obviously, if we know that one of the sides is x, because these angles are congruent, we know that the legs are congruent as well. So if this side is x, this side must also be x. Well, if you use the Pythagorean theorem and a little work on simplifying the radicals, you'll find that this length is whatever that length is times the square root of 2. Now, this all comes into play big time when we look at the unit circle. And what we're looking at again is a situation where our radius we know is 1, and that's going to come into play here in just a second. Hold on just a second. Let me clear out some things here. All right, so now I've cleared that off. And if I look at a situation where I know my hypotenuse is 1, and we'll talk about why I chose that in a minute, but it has to do with the fact that we're dealing in the unit circle. If the hypotenuse of this triangle is 1, and that is 2 times the length of x, whatever x is, this length down here, we know that this side, if you solve that equation, you're going to find that this length is a length of 1/2. And I know that's a little messy down there, but that would be 1/2. Now, if you take that 1/2 and you multiply it times the square root of 3, you got 1/2 times the square root of 3. To find this other side, that would be square root of 3 over 2. Now, that's important information, and I want you to put that in your pocket and hold on to it for a second. We'll come back to it in a minute and talk about it a little bit more. Going over to the 45, 45, 90, same situation. I know my hypotenuse is 1, and I know that these lengths are both the same thing. So I know that whatever this length is, we'll call x. I know that 1 is that length x times the square root of 2. So to find x, I would divide by the square root of 2. So I'd have 1 divided by the square root of 2 is equal to x. Well, we clean that up the way we know we should. We shouldn't leave a radical on the bottom. And we get that this length over here is the square root of 2 over 2. And because it's isosceles, we know that this is also the square root of 2 over 2. Now, that is all very important information. And we're going to relate it to the unit circle here in just a moment. But that's very important for us to understand. Our sine value, say for instance we wanted to find the sine for our 30-degree angle here. Well, our 30-degree angle up here, and remember sine is the opposite over the hypotenuse. That would mean that the sine of 30 is 1/2 over 1, which would be 1/2. And the cosine of 30 would be the adjacent leg, which is square root of 3 over 2 divided by 1. And I know it's getting a little sloppy there, but that would make that square root of 3 over 2. But because our hypotenuse is 1 and we're dividing by that, whatever the lengths of these legs are is going to tell us what our values for that trig function are going to be. And that's the important piece that we need to know here. So let's take a look at this unit circle. Let me go down here. Let me see if I can pull one up here. All right, so here is the 45-degree angle. Let's say this is a 45-degree angle here. And it forms a triangle. Let's say this is our radius. We know that, and since we're dealing in the unit circle, this is 1. And we have this length here. And we have this length here. Now that is going to define what the coordinates of this point are. Remember, the coordinates of that point are going to be however far we move over on the x-axis and however much we move up on the y-axis will tell us the coordinates of that point. Now, the coordinates of that point are going to be based on the ratios that we looked at back here. Excuse me just a second. Here we go. All right, so we have a 45-degree angle here, and the opposite leg and the hypotenuse are going to tell me that I'm moving up square root of 2 over 2, and I'm moving over square root of 2 over 2. Now, I know I've done it in the opposite direction here, but what we have is this length here is square root of 2 over 2, and this length here is square root of 2 over 2. So my x-coordinate is square root of 2 over 2, and my y-coordinate is square root of 2 over 2. Now, what is the significance of this? Well, if we look at the sine and cosine values of this 45-degree angle here, you got the opposite over the hypotenuse, and you got the adjacent over the hypotenuse. They're both going to be square root of 2 over 2 and square root of 2 over 2. Now, what this is saying, and we'll come back here to this slide, the y-coordinate of that point that we're passing through on the unit circle, the y-coordinate is going to tell us the sine value of our angle. The x-coordinate is going to tell us the cosine value. And that's very significant. Now, the tangent, opposite over adjacent, is going to be the y-coordinate divided by the x-coordinate, whatever that is. So anytime we can identify the coordinates of that point that we're going through on the unit circle, we know the sine, cosine, and tangent values for that angle. And we can, because we know that is going to happen, we identify specific, or not specific, but certain values that we run into a lot. Starting with the 45, 45, 90 triangle, we know that each of these represents a 45-degree angle going around the circle. The circle is 360 degrees, but if we break that down into 45-degree increments, we have 45, 90 degrees, 135, 180, 225, 270, 315, 360. And of course, it would continue on. It would go to 405, 450, and so on as we identified coterminal angles. But what we're seeing here is that right triangle. Now, you remember we went back and we looked at that right triangle, and that coordinate that we just went through was square root of 2 over 2, square root of 2 over 2. Now, what that is telling us is that for any 45-degree angle, the y-coordinate is square root of 2 over 2, which tells us the sine of 45. And the cosine is the x-coordinate, which is also telling us the cosine of 45 is square root of 2 over 2. Now, again, if we go straight out to the right, our coordinates are 1, 0. That means that our cosine for 0 is 1, and our sine for 0 is 0. If we go up to the 90-degree angle, we have the same deal. The y-coordinate is 1, so the sine of 90 degrees is 1. We go to 135, and we see negative square root of 2 over 2 and positive square root of 2 over 2. So those are the sine, or cosine and sine of 135 degrees. Again, we're in a unit circle. Radius is 1, so we go to the left 1 unit, and our coordinates are negative 1, 0. And again, that tells us the cosine and sine. We go down to 225. Coordinates are the same, just the signs have changed. Negative square root of 2 over 2 and negative square root of 2 over 2. We go to the bottom 1 unit, and it's kind of cut off there, but you should be able to kind of see a little bit. The coordinates there are 0, negative 1. And if I go over to my quadrant 4, my coordinates are square root of 2 over 2, negative square root of 2 over 2. And again, here we are on the unit circle with 30-degree angle increments. So our first angle is 30 degrees. Our second angle is 60 degrees. Our third angle is 90 degrees. And we keep going. Fourth angle is 120. Fifth angle is 150, 180, 210, 340, 270, 300, 330, 360. And of course, if it continued to go 390, 420, and so on, it would just continue 450 and all the way around, identifying coterminal angles like we talked about yesterday. So let's take a look at what this is going to come out to be. And I know you can kind of see it there, but if we look down at this version of the unit circle with the 30-degree increments, so we're looking at a situation where this angle here is 30 degrees, and we have a triangle. Now, if you think about the 30, 60, 90 triangle, turned on its side, and we know the hypotenuse, the radius, is 1, because we're dealing with a unit circle. We know that this short leg, now notice it's turned on its side, so the short leg is over here now, is 1/2. Because this is 2x, and 2x is equal to 1. So we would divide by 2, and we get x is equal to 1/2. If we take 1/2 and multiply it by the square root of 3, that would tell me that this leg is square root of 3 over 2. And that's kind of hard to write small, but you can see I've got the square root of 3 over 2 for the length of this leg here. Now, that's telling me that as I went over here to this point, I went over square root of 3 over 2, and I went up 1/2. So those are the coordinates of that point. Square root of 3 over 2, 1/2. If I take that same example and I look at it like this, and let me clear that out, that triangle here out. If I look at it in this aspect from this angle, say this is a 60-degree angle here, and now I'm looking at this triangle. And again, this is 1, this hypotenuse here. So this would be the 1/2 down here, and the square root of 3 over 2 would be on this side going up. So my coordinates here would be x coordinate 1/2, because that's the distance I moved over to the right, and my y coordinate would be square root of 3 over 2 for that point. Now that's just for this point at 60 degrees. These coordinates here were for the 30-degree coordinates. Now again, and that's, like I said, that's telling us the sine and cosine values for each of these points. So we have all these angles, and now I can take these points that we have, and of course again we know the radius is 1, so we know the right, the up, the left, and the down coordinates. If I go to the 30-degree coordinates, that's going to be square root of 3 over 2, 1/2, like we said. The 60-degree angle is going to have the coordinates 1/2 square root of 3 over 2, which is the same thing, other just the numbers are just reversed because the triangle's been flipped a little bit. But that tells us right there that the sine of 60 degrees is always going to be square root of 3 over 2, no matter what. You know, you can carry it over to the 120 degrees. It's the same coordinates, except the x coordinates in this quadrant are negative. You go down here and both of the coordinates are negative, but it's the same measures. And you go over here in quadrant 4 and the measures are the same, except the y coordinates are now negative and the x's are positive, because all the points in that quadrant are the same. But these points are very important to us, and what you're going to need to do is you're going to kind of need to put some of these to memory. And I know that's going to be tough for some of you to conceptualize, but really we're talking about 3 numbers. You got 1/2 square root of 3 over 2 on this circle, and on the last circle you had square root of 2 over 2 as all the values there. So it's not like you're getting a lot of values or a lot of numbers to memorize. But those are very important numbers to us. So say for instance we wanted to find the 6 trigonometric values of a 30-degree angle. And we wanted to just list those off real quickly. So we have a 30-degree angle, and we know that a 30-degree angle is going to pass through the coordinates that were given. If we look back at the example we just looked at, the 30-degree angle is going to pass through the coordinates square root of 3 over 2, 1/2. Now, hopefully that's something that you'll learn and you'll memorize after a little bit of time. And we will then know that the sine, the cosine, the tangent, all those values are going to flow from this. Our sine value is going to be the y coordinate, so that tells us the sine of 30 is 1/2. The cosine value of 30 degrees would be the x coordinate, which is square root of 3 over 2. Now the tangent of 30 degrees is going to be the y coordinate over the x coordinate, so that's 1/2 over square root of 3 over 2. Now you clean that up, and you get square root of 3 over 3. You flip over the square root of 3 over 2, and you rationalize it out. You cancel out the 2's, and you're left with square root of 3 over 3. I'll let you figure that out. But we're going to find the other all six functions. You'll remember cosecant is the reciprocal of sine of an angle. So if I have the sine of 30 is 1/2, the cosecant of 30 would be 2. That's the reciprocal of that. The cosine of 30 is square root of 3 over 2. The secant of 30 then would be the reciprocal of that, which is 2 over square root of 3, but that cleans up to be 2 square root of 3 over 3. Then we have the cotangent of 30, and we flip square root of 3 over 3 over, and we get square root of 3. And I'll let you play with that and figure that out. But that's the value you get by flipping that number over. Let's take a look at an angle of 270 degrees. Now, if we look at the 270 degree mark on that unit circle, it is at the very bottom, and the coordinates there are 0, -1. Now that tells me that the sine of 270 is -1. The cosine of 270 is the x coordinate, which is 0. The tangent of 270 would be the y over the x, so that would be -1 over 0. However, you can't have that. That's undefined because you can't divide by 0. If we looked at the cosecant of 270, again, that's the reciprocal of the sine. So that would be -1 over 1, or 1 over -1. So that would be -1. And then we take the cosine of 270, and we reciprocate it, and we flip it over. So we get secant of 270 is going to be 1 over 0. So that would be undefined as well. And then we look at the cotangent of 270, and that is going to be 0 over -1. And that comes out to be 0. So there you have it. Those are the 6 trig functions for a 270-degree angle. And again, we just get that from the unit circle. So you can see how knowing these values for these very common angles is going to be very useful to us. You know, the 30, the 60-degree angles are both breakoffs of the equilateral triangle. The 45-degree angle is half of a 90-degree angle. It's also, you know, if you get a square and you cut it in half, you get 45, 45, 90 triangles. So knowing all these pieces are very important, because we encounter equilateral triangles and squares quite a bit in everyday world. Now, let's take a look at other circles and say we're not in the unit circle. In other words, we're dealing with a circle that does not have a radius of 1. So we still have a terminal side, and we can imagine it passing through a circle. So if that circle is a little bit larger, we just make an adjustment by dividing out the radius. In other words, the length of the radius has changed, so it's no longer 1. So when we have opposite over hypotenuse, where our hypotenuse is no longer 1, so we have to divide by the radius. So the sine of our angle is going to be y over r. The cosine is going to be x over r. And our tangent is going to be still y over x. So tangent is always going to be y over x, no matter your situation. All right, so let's look at an example here. So we're in a situation where we have an angle that's in standard position. Our side is outside of the unit circle. It's extending beyond the unit circle, but we're in quadrant 3, meaning we have a negative coordinate that we're passing through. And our sine is going to be -4/5. So we want to find the values of the remaining trig functions. So let's take a look at, and there you can try not to give the answers away there too easily. But say we're looking at a situation here where we're in a circle. Let me pull my circle up here, and here we go. Let me enlarge that a little bit. So say we're in a circle here, and we're outside of our range of a radius of 1, and we're in quadrant 3, and we know that our sine is -4/5. So I believe that's what it was, wasn't it? Yes, sine was -4/5. So that means that our y coordinate is -4, and our radius is 5, because sine is y over r. So our radius is 5. Our y coordinate means that we're going to go down 4 because it's negative, and we have to find our x coordinate. So you can imagine we'll use the Pythagorean theorem there. So we'll say x squared plus -4 squared is equal to 5 squared, and hopefully you'll find that x squared is 9, and we get that x is equal to 3, positive or negative. Well, since we're in quadrant 3, we know that we have an x coordinate of -3, and we have a y coordinate of -4. And we just did that by using the pieces of that triangle and the idea that our sine is always going to be y over r. So we put these pieces together, and we can find the other trig functions for this angle here that we're dealing with. So our sine is going to be, here's our angle here. Our sine is going to be -4 over 5. And I guess I should have drawn it on this side. I drew it on the wrong side because we went out this way and down. But you get the idea here. I guess I erased a little too much there, but you see the point here, no pun intended. We're going out 5, we're going down -4, and we're going back -3. So we get our coordinates from that. And of course our sine is going to be -4/5. Our cosine is going to be the x/r, which is going to be, in this case, -3/5. Our tangent is always going to be y/x. Our y is -4. Our x is -3, so we get a positive 4/3 because of negative over negative. Cancels out the negatives and becomes positive. So we have those values, and the rest just kind of flows from that. You can see we have our cosine, our sine, our tangent. Our sine was -4/5. That was given to us. Our tangent is 4/3 because it's positive. Our cosecant is going to be the reciprocal of sine, so that would be -5/4. Our secant is going to be the reciprocal of cosine, so that would be -5/3. And cotangent would be the reciprocal of tangent, so that would be 3/4. So once you find the first 3, you're just kind of flipping them over to find the other 3, and then you have all 6 functions. But that's in a situation where we're outside the unit circle. We're inside the unit circle. All we worry about is that x coordinate and that y coordinate, because the radius is 1 anyway, so we don't have to worry about it. All right, so here we are. We have a given point that's lying on terminal side of an angle in standard position. So we're in quadrant 1, and we are looking at the point 4, 3. So our x coordinate is 4, our y coordinate is 3. So we can find the x coordinate, or excuse me, the radius, by doing the Pythagorean theorem. X is 3, or excuse me, x is 4, y is 3. So 4 squared plus 3 squared would equal r squared, and we'd find that r was 5. So we'd go with that, and we have our sine is y/r, 3/5. Cosine is 4/5, our x coordinate over y/r, and our tangent is y/x, so that would be 3/4. You go through and flip those over. Cosecant is now 5/3, secant is 5/4, and cotangent is 4/3. Again, we're just flipping those first 3 numbers over to get the other 3. Say we have a point -2, 1. That is going to be located in quadrant 2. So our x coordinate is -2, our y coordinate is 1. We would do the Pythagorean theorem, and we would get that r is square root of 5. So we would have, for our sine, we'd have 1 over square root of 5, and that becomes square root of 5/5. Cosine is going to be -2 over square root of 5, and that becomes -2 square root of 5/5. Tangent would be our y coordinate over x, so that would be -1/2. It's actually positive 1 over -2, but you clean it up, move the negative down, or move the negative up to the top. Cosecant is going to be what you get when you flip over the sine value. So that would be 5 over square root of 5. You'd multiply out and simplify, so you get just square root of 5 there. Cosine reciprocated to secant would be negative square root of 5/2. And then we flip over tangent to get cotangent, and that means that our cotangent is going to be -2. Okay, so hopefully you're seeing how we can apply these coordinates to find our sine, cosine, and tangent. And I know I'm throwing a lot out at you real fast, so if you need to, you can go back and replay this. And again, if you're having questions, I can answer them for you. It's really not that complicated. However, I know it's a lot of new information, so it kind of seems complicated at first, but after you take a minute or two and grasp the concepts, it shouldn't be too bad. All right, so let's look at some practice problems here. I'm going to just kind of break out of this, and we'll look at these on the marker board. Let me see if I can pull that up for us. Okay, so we're going to start off, and we have a 45-degree angle, and we're going to find the 6 trig functions for a 45-degree angle. Now, when we have a 45-degree angle, the first thing we're going to want to do is we're going to identify the coordinates on the unit circle for that 45-degree angle. And if you go back and look at our notes, you'll see that that is square root of 2 over 2, square root of 2 over 2. And this is the x, this is the y, so that should tell us a lot. So our sine of that angle is going to be square root of 2 over 2, the y coordinate. Cosine is going to be square root of 2 over 2 as well. Our tangent for a 45-degree angle would be the y over the x, so that would be square root of 2 over 2 divided by square root of 2 over 2. That's going to be 1. So we get those 3. To get cosecant, we're going to flip it over. We flip over square root of 2 over 2, and we just get 1, or excuse me, let's just look at it like this. 2 over square root of 2. We multiply that out to clean it up, because we can't have a radical on the bottom, we know. So we'd multiply square root of 2 to the top and the bottom. And what does that give me? Well, that gives me 2 square root of 2 over 2, and the 2's cancel out, so we're just left with square root of 2. And you can kind of play with that and work it out, but that's what you're going to get there. Obviously, when we do this with the cosine, we're going to get the same thing, square root of 2. And when we flip over a value of 1, we're also going to get 1 for our cotangent of 45 degrees. So those are our 6 trig functions for a 45-degree angle. Now, here's something that you need to think about. In number 2, we're looking at the angle 5 pi over 6. Well, the other day we looked at how to look at an angle in what we call radian mode, and that's what this is. This is a radian measure of an angle, and we're going to convert that real quickly to degrees if you need to. And what that's going to come out to be when you multiply that out is going to be 150 degrees. And I know that's kind of sloppy, but we're at 150 degrees. So the sine of 150 degrees, and we'll look at our unit circle real quickly. Let's see if I can pull that up. Okay, so here we are at 150 degrees. So our coordinates are negative square root of 3 over 2 and 1/2. So let me erase that out, and you can kind of get a feel for what I'm doing. We have coordinates of negative square root of 3 over 2 and positive 1/2, or coordinates. So sine is going to be our y coordinate, so that would be 1/2. Cosine would be our x coordinate, negative square root of 3 over 2. Tangent is going to be y over x, and we flip that and multiply it out, and what we're going to get, I believe, is negative square root of 3 over 3. I guess I should have a negative down there, so I've got negative square root of 3 over 3 for that one. And then we find the cosecant, 5 pi over 6. Well, all we're going to do is flip this angle over, or flip this value over, and we get 2. We flip this value over to get the secant, so we have 2 over negative square root of 3. Well, when you clean that up, you have negative 2 square root of 3 over 3. And then the cotangent, when you flip this value over, you're going to get negative square root of 3. Now again, all you're doing is taking this and flipping it over to get the cotangent. All right, so that's real quickly how we find trig functions using the coordinates from the unit circle that we get on those angles. Now, sometimes, like I said, we will run into radian measures like we did in this second example here, and we have to adjust. So here's an example where we're looking at a terminal side passing through the point 3, 4. So that would be, let's kind of estimate that's up here at 3, 4. We are outside of the unit circle because that point obviously reaches out further. So we're looking at this situation here. We have this triangle. The x coordinate is 3, y coordinate is 4. So our sine, we have to find the r. So we'll do 3 squared plus 4 squared equals r squared. And hopefully you can see that that's 9 plus 16 equals r squared, and r is going to be 5. Now that's important for us moving forward because I know that my sine is going to be y over r. I know that my cosine is going to be x over r, and so on. So I have sine, my y coordinate, over r. So that'd be 4/5. Cosine is going to be my x coordinate, 3 over r. My tangent is going to be the y coordinate, 4 over x, which is 3. And now all we're going to do to get the other values are just flip these fractions over. Cosecant will be the reciprocal of 4/5, which is 5/4. The secant reciprocal would be 5 over 3. Tangent, or the cotangent, would be the reciprocal of the tangent, which is going to be 3/4. So real quickly, we find r, and then we quickly identify sine, cosine, and tangent, and cosecant and secant and cotangent of those values. All right, so now we're looking at a situation in our last example here. Suppose theta is an angle that is in standard position. Its terminal side is in the given quadrant, and we want to find the 5 remaining functions based on the fact that cosine is -1/2. So we're in quadrant 3, so that's somewhere over here, and we know that cosine is -1/2, so that means that x over r is -1 over 2. So that means that my x coordinate here is -1, and my r is 2. So I'm going to use that to find y. So I'll say -1 squared plus y squared, whatever that is equal to 2 squared. So I've got 1 plus y squared is equal to 4. We subtract out, and we find that y is the square root of 3. So we're just going to quickly use that information. We're at the coordinates, -1 square root of 3. I don't know, that's kind of messy down there, but hopefully you understand what I'm saying. So we know that cosine, so we're going to use sine of theta is going to be equal to the y coordinate, which is, we're in quadrant 3, so it should be negative, I'm sorry. Negative square root of 3 over our radius, which is 2. Cosine we already found. Tangent is going to be the y coordinate over x, so that would be negative square root of 3 over -1. That's just equal to positive square root of 3. And then we just get the reciprocal of these values. Cosecant of theta is going to be this number flipped over, so that would be 2 over negative square root of 3, which is going to be -2 square root of 3 over 3. Secant of theta is going to be cosine flipped over, so that would be -2. And then cotangent of theta is going to be this square root of 3 over 1 flipped over, so that would be square root of 3 over 3. Again, just going through quickly, we can find the values of all these functions for whatever angle we're dealing with, just kind of knowing that the x coordinate and the y coordinate represent certain things when we look at these rotations. All right, so you have some problems you'll see on your homework and your exercises there. So take a few moments and go through them. Please feel free to ask questions in class and speak out and come to me if you have any need for help. I look forward to talking to you in class, and have a good day.